Aloha, everyone, and welcome to today's show. Today we've got Andy, and I'm Jyunmi, and hopefully we will see a couple people along the way. So, again, thank you for joining us, everyone in chat, and everyone who is joining us a little later. Today we are going to cover some AI news, and of course, if you see my face, we're going to do an AI in science. This time, diving into the recent release from AlphaFold. So let's kick it off with Andy. Andy, what burning stories do you have for us today?
Well, in a stunning news item, like I didn't ever expect to be able to say this, but there was no AI news yesterday at all, and in fact, Claude did not release any new features. What? I'm just kidding. So let me just talk a little bit about Claude's release of what is being called Dispatch, although the discussion on Claude's page about it doesn't use that term. So I'm confused about that, but the newsletters are referring to it as Dispatch, and I think Dispatch is a nod to the whole idea that there's communication from a dispatcher that is sent to the taxi or whatever else that's out there doing the actual work. And this new feature is in Anthropic's terminology, it says assign tasks to Claude from anywhere in CoWork. And so you can now speak to your Claude CoWork instance, and it will have that conversation, whether it's coming from the Claude desktop app, whether it's coming from the Claude mobile app. So you can use the Claude mobile app to talk to a single persistent session in Claude CoWork. So you can start it at, home, for example, on your laptop. You can jump in the car. You can continue the conversation on Claude mobile app. And when you arrive at your desktop workstation at work, you can jump into Claude and it will be attending to you as part of a continuous session. And there are a few limitations they've suggested about this new feature. First of all, you have to be running the latest version of Claude desktop app. It's being rolled out to pro users right away. And it's going to be, to max users right away, and then to pro users in a day, right? So it could be that this is the day that it's available because it was announced yesterday. So instead of having to start a new session for each task, you can have a single persistent conversation with your assistant, Claude. So that's a really nice feature. And the other limitations are like you can't start a new thread. You basically have to live with that one large context conversation. Let's see, they had another one. It responds to messages, but you can't ask Claude to schedule a proactive reach out to you like that. So that's current. They call these the current limitations, which suggests very clearly they're going to fix all those things going forward so that this is a much more complete version of this ongoing 24/7 personal assistant conversation that you can have with the Claude system. It's one continuous thread. You can't branch it off or manage multiple threads at the same time. You just have to be with Claude that way. And there's no scheduled tasks. I think I alluded to that in terms of just proactive outreach, but you can't do scheduling of tasks, but you can schedule recurring tasks in CoWork. And I want to just mention that I spent the time to listen to Nate Jones' most recent discussion of using Claude in connection with the Claude MCP extension in Chrome. And that he described this way of recording workflows using the MCP extension. And there's an actual method that you can do that, where you could launch the Claude MCP Chrome extension. And in the conversation with Claude there on the browser, you can start a recording and you can then speak out loud and describe to Claude what you're doing as you're clicking through a series of steps that you may have to repeat every day. And then you finish that recording. You then can schedule that action by Claude on a routine basis. So if you're doing the same thing every morning and having to check various browser tabs and put things together, and you can imagine that many enterprise workflows in business processes are like that. And it's just in Chrome. Obviously, you use Chrome to go to lots of different things, including your logins to various platforms. Well, Chrome can now with the Claude extension, it can record that and then manage that repetitive workflow as an automation. So I thought that was really an important thing to get, is that you can, with the Claude system now, do workflow automations pretty easily just by recording them in the Chrome MCP extension and then scheduling them in CoWork. I would suggest you use CoWork, but you can also do it in the CLI and Claude Code and have it run that Chrome extension recording. And it doesn't just play the recording back. It knows that recording and it follows the instructions basically that are inherent in that recorded workflow.
I mean, it's interesting. It does seem like they're answering especially with dispatch, they're answering the communication tools that people have built their own thing, right? There's the whole build to use like OpenClaw with a messaging app and things like that.
Yeah, one of the, by the way, with respect to OpenClaw, one of the newsletters, I think was AI Breakfast, had as their headline, Claude introduces their own claw.
Yeah.
And they were referring to Dispatch, which gives you the mobile interface, which is a key feature of the Claw system design. Like you communicate with it via Telegram or WhatsApp or whatever. Well, in this case, you don't use one of those other things. You just use the Claude app on your phone.
Right. Now the interesting thing about the MCP is it's not specifically designed to do that, or
well, the MCP is a different thing. The MCP is the way that you give Claude access to your browser and basically give it access to a computer so that it can then navigate the web. It can actually, read everything that's on those pages. It can type into those pages. It can understand them and take actions on those web pages. So now you have an active agent that you can direct via various communication channels in the Claude ecosystem, and then it'll act on your behalf in a repetitive way. If you've given it a recording, it's sort of established a workflow, or with its own reasoning and good judgment, we hope, go about navigating the web. And I talked yesterday on the show about a simple use case example where I'm using a Perplexity computer to do that. But now I could easily do the same thing with, and even on that day when I was playing with Perplexity computer to do that, you can do that with Claude and its browser extension in Chrome.
Gotcha. Yeah, it's I do like the show don't tell aspect of that application, so I'll have to give it a shot myself. Just joining us is Danielle. Hi, Danielle. How are you?
She's good. she's on mute, but
I'm trying to find where all the controls are. So sorry, my alarm didn't go off. So
no problem.
Here, and now
I'll give you a moment to drink some coffee before I throw to you for a news story. So I'll cover a quick news story first myself. This is minor in the grand scheme of things, but I thought it might be interesting to mention is that NVIDIA has shipped their DGX stations, their new ones, to all of their big time developers and AI engineers and things like that, like Andre Karpathy. Now,
Now,
until
wait,
now.
is that the sort of desktop computer that's like fully powered with a Blackwell?
Yes,
Yeah, okay.
yes, that's the station and not the Spark, which is a real good distinction. The Spark is supposed to be the quote unquote affordable one, at like $4,000, $5,000, and then these new DGX stations are run about 100K.
Oh,
So not an everyday
I thought
computer.
you were going to say 10K, but
No,
no, it's
no,
order of
yeah,
magnitude
100K.
more expensive.
Yeah.
Okay.
So what was interesting is they did, because GTC is going on now, and Andy, I think you covered a bunch of NVIDIA news yesterday. But this new station is powered by the GB300 Grace Blackwell Ultra Super Chip. All right. Um, and so what the hope is for these kinds of stations is to put AI developers and engineers having some hardware that they can use to actively crunch crunch some numbers and build new models and do testing and experiments and things like that. Um, so not the most important thing that goes out there, because NVIDIA, dips their toe into all kinds of waters there. Uh, but what I found interesting is some of the technical specs of this station on its surface seem that doesn't seem like the price matches. So it has a 72 core CPU built on ARM architecture. Nothing new there. The 72 core is
Big
that's a
stack.
pretty that is
Big
yeah that
stack. Yeah.
yeah. Um, it's connected by a 900 gigabit per second link, right? That's the data link, and it has 784 gigabytes of unified memory. Right, that's both the high performance RAM, um, and high performance storage type RAM. So first layer 1 and layer 2 type of memory. Now, what's interesting for the GPU, sorry, I should have clarified there. So what's interesting with this is if you compare it to a top end Mac Studio, it's pretty close. Now, there's, I believe, 12 more cores, like a Mac Studio. Someone please correct me. I think it's got about 60 cores or something around there. And it can run with 512 gigs. This is the current version, not the supposed M5 Ultra that'll be coming out soon. And it has 800 and something gigs of bandwidth as well. So is that small jump, or relatively small jump, the reason why they're getting 20 petaflops of compute? And I know petaflops or flops is not the end all be all or factor of compute hardware, but it on paper it doesn't look like why is it 100K, right, when the other one's like 10. So I'm just wondering if this is an NVIDIA just volume price markup kind of thing, because they only plan to make 10,000 units as opposed to 1,000,000 units, and what kind of the thing they're going to develop with the hardware. Now, the important thing is this is supposed to help developers make their own models, but I don't know if this space, and it's a particular interest of mine, is I want to see more open source AI development, and I want to see more models, useful models, come out into open source. So maybe there's going to be some movement in this area, because I've been having my eyes on that maxed out Mac Studio, and I think a couple months ago, they did a cluster. They did a specialized cluster of 4 of them, and we're getting some really, really good results from
So, Jyunmi, tell us what the price comparison is between those. So, I was thinking, okay, maybe it's the amount of DD or whatever the latest version of the best RAM is that's so
Right.
expensive right now because it's in such demand.
Yeah.
Prices have been skyrocketing for RAM, and it's difficult to get computers, including Apple computers now, with the very large RAM installs. What is the maxed out Studio? Say again the RAM
Right. So
and what's the price for that?
Yeah, the current maxed out Studio for RAM is 512 gigabytes.
Okay.
So, so when you go to buy the Studio is like 4K, and
Yeah.
then you basically double it for putting in the maximum amount of RAM, right? Now you're able to load significantly sized models with this, and it's rumored that the next version, the M5 Ultra version, is going to come out with a terabyte or 1.5 terabytes of memory, and the RAM does has increased a lot, like you said, because of the demand, but but a lot of these companies, especially for a company the size of Apple, they enter into these multi-year contracts with the RAM manufacturers to at a certain price point. So it may be another year, or if we're lucky, 2, before we start seeing even price hikes, or really big price hikes in that time for this hardware. And just so for everybody knows, there's only 3 RAM manufacturers out there, right? There's essentially Samsung, Micron, and I think SK. I can't remember, SK something. And essentially, Apple gets its memory from Samsung. So these are 2 powerhouse companies, and Samsung's manufacturing to create contracts for years and years on set prices and things like that. So hopefully, we'll see that stay relatively even over the next couple of years. After that, though, we're looking at like 5-6 years before the new fab facilities they've planned will be online. But I digress. The main story was to highlight these new DGX stations, and I'm not exactly sure what is NVIDIA putting in there to make it $97,000 as opposed to more near 10 or 20.
So Cisco says here that he has an M4 Max Studio. M5 only very recently came out, so it's probably a recent purchase, Cisco, and he has 128 gigabytes in it. I have an M4 Pro with 48 gigabytes. That was my sweet spot in terms of what I was willing to spend, because I think things are rapidly advancing here. I'm curious if you'd share with us. I will promise not to share it in the actual live feed. But if you'll share with us in the chat what that M4 128 gigabytes cost, that give us here on the show anyway a little perspective on the alternative to the incredibly expensive NVIDIA system.
Mm-hmm.
Danielle, we are inviting you to tell us the news of the day here. What's up?
Well, I have to admit that I don't have the newest of news of the day because I haven't checked the news of the day in the morning routine yet. But I will say something that I saw across TikTok, which is where I get my news, by the way. So let's just clarify that one. TikTok is my life's forecourt. What I found was really interesting when I was catching up with some things is recently, over the last few months, there's been a lot more ideas around AI hiring humans to do human-like tasks. And I don't know if you guys had discussed this earlier, which I find hilarious in so many ways because the robots haven't caught up apparently. But while I was catching up on that information, and I think I heard about that in, I want to say, early February timeframe, was the fact that the AI is having a hard time finding humans to do these tasks, even though the ratio is probably 4-to-1. So there's 4 times as many humans that can do a task than the AI will be willing to hire. There's so many Terminator explanations to all of this that I keep wondering about, to be honest. But what I found interesting is they said that they had 30 applicants to go do like a DoorDash kind of thing, take one package from one area to another area, and 30 applicants, they were going to pay $40, and the AI refused to hire any of them. And all of the 40 applicants that looking at them had like driver's licenses, could do the job, all these, they're already DoorDashy people, already doing things with Amazon delivery, something like that. And the AI still refused to hire them for one reason or another. And I never got past that area of wondering like, why didn't the AI hire him? But also, AI should be lazy and start doing it itself. I saw that, and yes, it should. And then I was like, well, maybe they have Gen Z problems going on where they're like, they're saying Gen Z people are so lazy that they're not going to be able to do it, or they're asking too many questions about where it is. I don't know what's going on, but the fact that this is happening makes me laugh internally on such a level, and maybe externally, but also also going, where is our communication going? Where is society going? Where is all of this going? If we always think of AI helping us, but if the tables have turned and now AI needs us to help them, it's becoming very Matrix. It's becoming very putting us into a pod and doing something. And I thought that was the most hilarious thing I have heard in a long time. Not just the fact that it was happening, but the fact that AI was having problems hiring people because they didn't pass the qualifications that AI had in its make-believe head. I don't know where to go with that, but it is commentary that I think that's worth like laughing at a little bit. But also, is this the future? And should I be scared? Because I love AI, but now I'm a little bit like, I don't know if this is the direction we want our weekend spin-ups of SaaS models going. But anyways.
I wonder what kind of tasks the AIs are actually feeding out to these people. Did they give any examples of the kind of things you can sign up to do?
Yes, there are examples. Hold on. There's like things, there's actually one job. It's called Rent a Human. So if you guys want the URL, it's called Rent a Human AI is one of the more popular ones that people are talking about, and stuff like that. There are things like hold a sign up for 1 hour that says rentahuman.ai, literally advertising things on street corners. You know how people have the subway signs, the Quiznos signs, and the same thing, that kind of thing. Dropping locations off. So for legal documents, you have people that can drop off, you need a courier to go do things like that, and stuff like that. Some of them are really short, like get something notarized or something to that effect. Anything that has to have like a human, usually these are physical types of jobs, getting pictures at a certain location at a certain time, attending a meeting, running errands, those types of things. And so very DoorDashy, quick kind of things that only a human can do at this point.
And humans should have good judgment about the request by the AI to pick up the bag that's next to the bench in the park and walk it down a way until someone says to you, "Hello, I'm assigned to get that bag from you." That you should probably wonder about the instructions on that.
This is just going into pure comical. Like I can see this as a black satire on some movie about the CIA using this to like transfer details and stuff like that. Pick up the little, hard drive underneath of the garbage can and transfer it over to another garbage can and put it in there. That's awesome, Andy. I love that. We've seen this movie before. Yes, Greg, we have. We've seen this movie before. Humans have, and also, please, humans have great judgment or good judgment. We aren't the smartest ones out there. But anyways, that is my news of the day because I thought It's so funny. Like, I know we talk a lot on this, like the new chips that are coming out, new technology that's coming out, and all those other kinds of things. But the fact of the matter is while that's all really important to talk about, this also integrates into our day-to-day lives, and having conversation, even the humorous ones, around that interaction within our daily lives is just fascinating to me. It's so fascinating. So there we go. That's my news.
Yeah, I agree. Definitely want to take a macro view of some of the trends, right? So, but I do like your idea of a sitcom that is about the CIA using CIA AI
Yeah.
using using TaskRabbit or
Yeah.
whatever they call it. Okay, yeah, I can see it coming this summer of
Come here.
2026.
Yeah. Yeah.
Yeah. Yeah, no, and that'll be good. Well, and then while you were laying that out, I was just thinking, well, that's only until they get more of the robots to do the tasks, right?
Exactly.
Wasn't Beth talking about how they were showcasing a bunch of um, robots and Unitry and things like that yesterday? Talking about how these relatively low cost humanoid robots are performing more and more tasks or training and things like that. So we'll see. We'll see. It'll evolve from just sandwich delivery to whatever that task is, right? Though, yes, I agree, Andy. Let's not move unmarked bags from park benches over to secondary locations. That doesn't sound wise. All right. So as we move on, Andy, do you have another story you want to cover today?
Well, I'm not going to cover it in depth, but as you know, I keep a thing in Notebook LM all about the beyond Transformers announcements, and there's a lot of discussion among the big thought leaders in AI about whether transformers, the LLMs that we work with today, that are very competent, can really achieve artificial general intelligence, and what will it take to actually get there? And there were just a few skeptics about LLM and the premise that you could just scale these things to the point where you'd get to AGI. And now there's a larger group of them out there who are all saying, no, it's going to take a different kind of model entirely. And world models are, in our discussion path. But the other one that I wanted to bring to your attention is Mamba, which is a different architecture entirely from a transformer. And Mamba 3 has just been released. That changes the method of attention that's used in these things. In this new Mamba 3, it's a state space model. That's this different architecture. And Mamba 2 was that as well. But they haven't displaced LLMs at this point, but they are a major contender for what might ultimately replace the transformer architecture. But it's hard to displace it, obviously, because it's so wrapped up in everything that's being done now, including, the implementation of huge data centers that are optimized to run transformer architectures. So, but Mamba is moving forward, and it gets a lower perplexity score than transformers do, and it's got a bunch of details. I'm not going to go into those right now because I haven't even studied it carefully. But I'll update those things, and in a future show, I want to talk expressly about, what's happening in the sort of ongoing efforts to replace transformers as the heart and soul of what we understand as AI today.
Right. I guess a quick side question: is Mamba a parallel technology development, or is it like new? Meaning parallel to LLM or transformers?
Well, no, it's completely a separate track. It's a state space model. Yeah.
Right. But has it been in slow development over years?
Yes, it has. Mamba has been around for a while, and there are hybrid Mamba LLM models out there where they put the two together in order to take advantage of the capabilities of Mamba architecture, the state space model, which has, like a simple way that I try to understand it is a state space model has an architecture in the deep neural network that is represented there. It has a way of passing forward what the most recent state was of a certain conclusion or representation that's in the model. Whereas a transformer doesn't retain that. It doesn't change its state as a result of processing inference. But a state space model somehow, and it's worth investigating it because it has implications for memory by a model. It has a way of retaining that the state of a prior step in the thing and holding that. So anyway, that's very short shrift on what is a very complex discussion, but I'll try to simplify it, or I'm sorry, I will have Notebook LM simplify it so that we can all understand it. But Mamba is an important architecture. That's one of these, not the only one. There's MF cons, like, that's the latest and greatest one that I'm kind of curious about, and I'll start to do some study about.
All right. So a future Andy deep dive.
A deep dive on the next wave of models that surpass and potentially replace the effectiveness of LLMs for us.
Nice. Okay. Well, go ahead.
I was going to say, because you mentioned at the beginning of that, Andy, if you about the idea of consciousness and if this would be a new way for AI to kind of have a relative of consciousness. And I don't know if you guys have talked about this before, but I think a lot of people maybe confuse consciousness with reasoning, or they kind of overlap in so many different ways, right? And so the first question is, I think, does AI understand, which comes to that back and forth memory context that we're talking about. But when it comes to consciousness, even I like Mamba music, even humans can't define consciousness. Like, that's a question that has been asked over and over again. How do you define consciousness? So I feel like a better question to ask is, and again, I don't know anything about Mamba myself either, so I can't wait for that deep dive. But I think understanding context and does it understand is actually a question that needs to be answered, because if humans don't know how to define consciousness, do we have consciousness? Does a cat have consciousness? Does a dog have consciousness? What does have consciousness? Because you can't really relate that in brain stimulation and all that other kind of stuff. It's almost like a gut feel that we each have, which goes down the path of, spirituality, fifth dimension, woo-woo crap, right? That goes down that direction rather than a tangible question. So it might be a form of consciousness, but it might be not the same type of consciousness that we experience versus what a tree might experience. I don't know. Maybe a tree is conscious. Who knows, right? So we can't define that. So what I find interesting is we are talking about a lot about AGI or conscious and stuff like that, but what's really going down is, does AI understand enough to be able to mimic that information when what makes us human versus what doesn't make us human? And I always go back to the Star Trek with Data, because I love Data. Data is like, we're hearts on Data. We love Data, right? But Data was presumed to have a consciousness, but it was also an android. So did it have consciousness, or did it not have consciousness? There are two different meanings. And when does that happen? When does the consciousness happen? I find that topic super fascinating to have conversations around it. There is no answer, which makes me feel great because I can never be wrong. That makes me super happy. I don't want to be wrong for a variety of reasons, but I think I would love to know the parameters on what they're using to make that decision. And when people have these conversations, what is that meaning of consciousness that they're using? But should they really be asking, does it understand the complexities that humans understand to be able to make the correct decision that most humans would make? And that solves another problem. Humans don't know how to make a decision for the life of us. Like, I'm dumb as a rock. Like, apparently I don't know how to set my alarm loud enough to be able to wake up to get in here. Like, where are we going with that? That was just a cute little take that I had when you said that it's a new way of doing it. And I think it's fascinating that we're finding new ways to move this technology forward, to dive deeper into this understanding, to be able to humanity.
So I like the thread, threading off of, more advanced models. And I think that the ones that are more likely to achieve something that's a simile of human consciousness will be those that are sort of neuromorphic computers, meaning they're based on the biology and the system of human brains. And recently we came across a news item where somebody had developed a mathematical model that was more akin to the actual structures of the neural network that is our human brain. So they managed to map that with some kind of, exhaustive, intensive imaging of the activities of neurons in a human brain. Or I think they did it on a mouse brain or something. They started with something smaller, and they're working their way up. But eventually they'd be able to map the human brain. If you then assembled something that was like that, you'd be closer to what our experience of consciousness is than you would get through text training an LLM with its vast store of knowledge, which is not like our consciousness, right? I have identity and a sense of my mind, and I have a theory of mind. I extend that to you two, at least, right? That I know that you have a similar kind of mind and consciousness, but I don't expect you to have exhaustive knowledge of the universe. That's not the test of mind. Like, you can have a very simple mind without very much knowledge at all, but it's still nonetheless aware that is a unique entity, and it is, has some persistence and continuity. And that, I think, is an interesting question about consciousness and awareness, because, is useful consciousness lost when Alzheimer's, for example, erases all of the reference back to the continuity of your existence to the point of your earliest recollections? Yep. Now you have none of that. You're just operating in the world in this moment, and you don't have anything that's connected to the past. And yet you're borrowing from all of the experience somehow in order to represent yourself as being competent, at least in conversation and so on, even though you might repeat the same thing over and over without any knowledge that you just said it. Is that consciousness, or is there a distinction we have to make around consciousness and what is practical or useful as an expression of consciousness? So anyway, theory of mind, I think, is a key one. If I know about myself that I have a mind, and I can understand that you also have one, that's for me anyway. That's the test of whether I'm a conscious being.
I want to say there is a checklist of things that are evaluated for consciousness or sentience, right? Now, I might be drawing on my sci-fi knowledge a little much in this, as opposed to science itself. But if you do watch a lot of sci-fi, you'll know that they'll talk about self-awareness, like Andy said. They'll talk about preservation. They'll have a sense of preservation that goes to proving that it's a sentient creature or sentient species. And there's, maybe this is just life form or whatnot, but propagation of some sort, or what, commutative networks, those kinds of things. But like both of you said, it's something that we have to be aware of, as long as, because is it a goal, right? Is it a goal of this development to reach that point? And with Annie, like with this Mamba, what did you call it? Did you call it stateful?
State space model. That's the architecture that is Mamba.
And I found it interesting with your your analogy to Alzheimer's, because it sounds like Mamba, with its architecture, allows you to remember things, or allows the model to remember things, whereas
in a rudimentary way, yes.
right, in a rudimentary way, right? And I know, I am red string theorying these pieces for sure,
Yeah.
but it that's what hit me. It was like, oh, Alzheimer's is you forget, you have the information, but its point in time and its linear timeline becomes disjointed for you. That's like not being able to remember the previous session or remember the previous state. So, um, and like you said, there is a lot of research being done to see the what do you call it, neuromorphic
computing,
neuromorphic design, where matching the human brain in computer models and things like that. So interesting.
So
and let's not forget the organelles also. I love bringing that up. So Beth, if you're still in chat, organelles. Sorry, she doesn't like them.
So going back to Mamba, Mamba has efficient memory in the current context, right? So it knows what the model retains what's going on there, but it doesn't have representations of everything it's ever known. It's more like a short-term memory, and if you create a hybrid, which is the combination of a transformer for this long-term storage of vast knowledge with a state space model that has the ability to keep a short-term memory and manage context of the current conversation better, the combination of those two gives you a better approach to artificial general intelligence, I think, than either one of them alone.
Yeah. All right. So Andy and everyone else, join us every single day until Andy shows us the deep dive into Mamba.
It's on my to-do list. I'm gonna do that, but
All
not
right.
just Mamba. There's a whole ton of other ones. I can actually pull up this.
I think this is very interesting. Is I just pulled up the Mamba paper on it, the Mamba 3 improved sequencing model, and right, using state space principles. And there's no way I'm not reading this. Like, the whole thing is a rigmarole of math equations, like the whole paper. And so I am looking forward to Andy translating all this into human language and stuff, because, and I like even the methodology, which is just one paragraph, has, by the fifth word, I don't know what they're talking about. Like, that is not a real word. I don't believe it really exists. I'm also, though, the firm belief that math is not math the second that you add a letter to it. So that's where my brain goes. Like, it's not, if you're adding letters.
Yeah, I'm not a mathematician either. I have a faint grasp of conceptual mathematics, but I could not do any equations or be in a physics department again.
Yeah.
But here, let me rattle through a list of some of the candidates of the architectural leaps, the Beyond Transformers collection that I have running here. So we talked about Mamba and state space models. That's one of them. Then there's recursive language models, which are REPL environments. That is a different approach to language models. There's manifold constrained hyperconnections. Okay, that's another kind of area that I don't even understand. There's JEPA, and Jan LeCun is big on JEPA, which is joint embedding predictive architecture. And it has variants like the visual language version of JEPA, VL-JEPA, which we've seen work effectively in the video space. There are neurosymbolic AIs, and that's this idea of capturing concept representations that are static, that are fixed, that are representative of real truths that exist out there in the world, rather than just what you've heard through text or audio or video. and somehow reasoning models could distill down to these symbolic elements in the neurosymbolic architecture, and those ground the artificial intelligence in real world physics and everything else. And then we talked about neuromorphic computing. And then there's finally a bunch of different developments of Kolmogorov-Arnold networks, which we talked about in 2023. And now there's quantum Kolmogorov-Arnold networks. And those, the combination of quantum technologies and CANs, K-A-Ns, may well be at the cutting edge of what artificial intelligence architecture is in the future. But all of these are on the playing field, all working towards artificial general intelligence, and many people now, including I think recently, Sam Altman has acknowledged that it's going to take something more than transformer scaling to get us to AGI.
Gotcha.
Even though 6 months ago he was kind of teasing the idea that they already had AGI behind the curtains. No, he's now saying, no, it's going to take something else.
I might have missed it. Did you mention like world models, Jan LeCun?
Well, no, not specifically. World models is a way of training any one of these architectures, including LLMs, so that they are multimodal and trained in the real world, right? So, and that's a key step. I think JEPA is, just putting two and two together. Jan LeCun's big fan of JEPA. He's also building a world model thing. I think that you see the marriage of that particular architecture to world models is probably the path that he's taking. But I haven't dug into that or ascertained that in any way.
Gotcha. Okay.
Definitely looking forward to that. I want that conversation because one, I think it's the fourth one. I do believe it's the quantum. I don't think we can do Jack Black without the quantum going on. And also it interests me on so many different levels. I also want to propose, why are we doing that? Why are we such a rush to give them consciousness / the AGI, whatever things? Why are we doing that? And then also I can't wait for it because quite frankly, I don't want to use my brain anymore. I'm very tired. I'm very old.
Oh, come on.
Well, on that note,
I can look at your face and I know you're not old.
Oh, it's Botox and Clairol. It's nothing but Botox and Clairol. That's all there is, right?
Technology. It's just
technology. Yeah.
All right.
Okay, we'll have to compare digits after the show, and then you'll know what old is.
All right, so that's an after show conversation. And speaking of which, if you want to continue the conversation, please join our Slack community at dailyaishowcommunity.com. All right. So Danielle, I'm going to give you a moment to sit back and relax and listen to the dulcet tones of Jyunmi Hatcher as he talks about AI and science. Okay, everyone. If you've been following AI even casually over the past few years, you've probably heard a name that keeps coming up in conversations about science: AlphaFold. It's the AI system built by Google's DeepMind that solved one of biology's oldest and most important puzzles, predicting the three-dimensional shape of proteins. Those tiny molecule machines that do essentially everything in your body. That breakthrough was so significant that it won the Nobel Prize in Chemistry in 2024. But here's the thing most people don't realize. Knowing the shape of a single protein by itself is only the first step. In real biology, proteins almost never work alone. They pair up, they snap together into complexes that switch signals on, form channels, or in the case of a virus, dock onto human cells to start the infection. The real prize, the one that could change medicine for billions of people, is understanding how proteins interact with each other and then using that knowledge to design entirely new molecules that can treat disease. That second step just got a whole lot closer. And it happened this week, right here at NVIDIA's GTC conference, and in simultaneous announcement from one of Europe's most important scientific institutions. So, to understand why this week's announcement is so important, you need to understand what proteins actually do. Because they're not just something you eat for breakfast. Proteins are the workers of biology. They carry oxygen in your blood, they fight infections in your immune system, they send signals between your brain cells, they copy your DNA when your cells divide. There are more than 200 million known proteins across all living organisms. And virtually every disease you've ever heard of, from Alzheimer's to cancer to diabetes, involves proteins that are either broken, missing, or behaving in ways they shouldn't. For decades, one of the biggest bottlenecks in medicine was that scientists didn't know what most proteins look like in 3 dimensions. And the shape of a protein determines what it does, just like the shape of a key determines which lock it can open. Before AI, determining a single protein structure could take a PhD student years of painstaking laboratory work using techniques like X-ray crystallography, where you literally bounce X-rays off of frozen protein crystals and work backward to figure out the shape. Entire careers were built around solving just one protein. Then in 2020, AlphaFold changed that equation overnight. Google DeepMind's AI could predict a protein's 3D structure from its genetic sequence in minutes instead of years, with accuracy rivaling laboratory experiments. By 2022, they had predicted structures for virtually every protein known to science, more than 200 million in total, and made the entire database free and open to researchers worldwide. It now has more than 3.4 million users across 190 countries. The scientific community called it one of the most important advances in history of biology. But there was a crucial limitation. The original AlphaFold database predicted the structure of individual proteins in isolation. A single protein by itself is like seeing one wrench on a table, useful but incomplete. In reality, a lot of biology only makes sense when the parts connect. Sometimes two proteins snap together to switch a signal on. Sometimes they form a channel. Sometimes a virus protein docks onto a human protein and starts the process of the overall infection. Understanding these protein to protein interactions is the key to drug discovery. Because most drugs work by either blocking or enabling those connections, if you want to design a drug that stops a cancer protein from activating, you need to understand exactly how that protein connects to the other proteins in its signaling chain, and where a drug molecule could wedge itself in to disrupt the process. So this week, EMBL's European Bioinformatics Institute, one of the world's leading biological data centers, announced a major collaboration with Google DeepMind, NVIDIA, and the Seoul National University to massively expand the AlphaFold protein structure database with something it never had before: protein complexes. The partnership has calculated predictions for approximately 30 million protein complexes overall. Of those, 1.7 million high confidence predictions have been added directly to the searchable AlphaFold database. These first 1.7 million are specifically homodimers, meaning two identical copies of the same protein bound together. That matters because many medically important proteins only reveal their true functional shape when two copies pair up. The EMBL team highlighted a striking example: a protein from a slime mold that looks completely disordered on its own, essentially shapeless. But when modeled as a homodimer, the two copies intertwine into a stable, meaningful structure. So, what does this mean in plain English? The important biology was invisible until the pair was viewed together. Now, another 18 million lower confidence homodimes predictions are being made available separately in a bulk download. and the rest of the 30 million are heterodimers, pairs of two different proteins, which are still being analyzed and assessed. The heterodimers are where a huge amount of medically important biology lives, because most drug targets involve interactions between different proteins, not two copies of the same one. So the EMBL says more predictions will be added to the database in the coming months. So to put the scale in perspective, before this week, the most comprehensive databases of experimentally determined protein complex structures had been accumulated over decades of global laboratory effort. This single release dwarfs those collections. Nature called it a next level step for the AlphaFold database, a phrase that originated with the Martin Steineiger, the computational biologist at Seoul National University who helped lead the effort. There's a number that captures the democratization angle. EMBL says the collaboration is essentially hosting data that would otherwise require 17 million GPU hours to recreate from scratch. By making these calculations once and publishing them openly, a graduate student at a small university now has access to the same molecular data as the team at a well-funded pharmaceutical company, so no expensive computing infrastructure required. The AlphaFold expansion gives scientists a better map, but at GTC this week, NVIDIA also introduced tools designed to act on that map. Proteina Complexa is a new AI model built on NVIDIA's BioNeMo platform for life sciences. Unlike AlphaFold, which predicts how existing proteins look and interact, Proteina Complexa generates entirely new proteins, molecules that don't exist in nature. Designed to bind to specific target proteins in the human body, in the language of drug development, these are called protein binders, and they're one of the most promising frontiers in modern medicine. If the AlphaFold expansion gave scientists a detailed map of every lock in biology, Proteina Complexa is learning to design custom keys. 3 major pharmaceutical and biotech companies, Novo Nordisk, Viva Biotech, and Manifold Bio, are already using Proteina Complexa to design candidate drug molecules, and they've begun experimentally testing those AI-generated designs in the laboratory. Novo Nordisk is one of the world's largest pharmaceutical companies, best known for developing Ozempic and Wegovy. When a company of that scale and scientific reputation starts running real experiments on AI-generated drug candidates, it signals that this technology has moved past the research phase. NVIDIA also introduced NVQSP this week, a GPU-accelerated simulation engine that lets pharmaceutical researchers run far more treatment scenarios in computer models before a single drug candidate enters a clinical trial. In benchmark tests, NVQSP delivered up to 77 times faster performance compared with traditional single-threaded CPU simulations, allowing scientists to analyze hundreds of dose levels and patient subpopulations in the time it previously took to simulate just a few. In traditional drug development, this simulation bottleneck is one of the biggest reasons promising molecules get stuck in the pipeline. So here's the broader picture. Developing a new drug today takes on average 10 to 15 years from initial discovery to the pharmacy shelf. The widely cited average cost is more than $2.5 billion, and roughly 90% of drug candidates that enter clinical trials ultimately fail. Those numbers have barely improved in decades. They're the reason why many diseases, particularly rare diseases, neglected tropical diseases, and conditions that primarily affect people in low-income countries have no effective treatments at all. The economics simply don't work. If the patient population is too small or too poor to recoup a multi-billion-dollar investment, pharmaceutical companies often don't pursue the research. AI has the potential to change that equation, not by replacing laboratory science, but by giving scientists dramatically better starting points. Better maps mean fewer dead ends. Faster simulations mean more candidates get evaluated before expensive clinical trials begin. And open data means the tools aren't locked behind the gates of the richest institutions. Now, Eli Lilly is pursuing this vision aggressively. Last month, the company inaugurated LilyPod, an AI supercomputer built on NVIDIA DGX SuperPod with 1016 Blackwell Ultra GPUs, delivering over 9,000 petaflops of AI performance. Lilly's VP of Research Informatics, Yua Wang, Webster, said that the system breaks the physical limits in a traditional wet lab, where a productive lab team might rest roughly 2,000 molecular hypotheses per target per year. LilyPod can simulate billions in parallel. The company's stated goals is compress drug discovery timeline significantly through exactly how much remains to be proven. To maximize global health impact, the EMBL collaboration deliberately prioritized proteins tied to the World Health Organization's priority pathogens list and 20 of the most heavily studied species, including humans. That means this resource isn't aimed solely at basic science. It's designed to address urgent global health threats from antibiotic resistant bacteria to emerging infectious diseases. Dame Janet Thornton, Director of Emeritus of EMBL EBI, framed the biggest picture in terms that capture the ambition. Adding predicted protein interactions to the AlphaFold database is the first step towards describing the human interactome, the complete network of protein interactions in the human body. The human genome has just over 20,000 different proteins, but the complexity of human biology arises overwhelmingly from how those proteins interact in vast combinations. Science is shifting from asking what does this one protein look like to asking who does it work with and what happens when that partnership breaks. So big news from AlphaFold, big news in the biology and chemistry world. And hopefully we will get better and faster cures for some of the world's most deadly pathogens and diseases. And that's our story in AI and science this week.
Thank you. And as long as the cure for the diseases, the compounds that are developed don't require that you get vaccinated, it might actually be implemented in the world. But now there's so much vaccine skepticism that it's causing things like measles that we already had, a conclusion for, to kind of rear its ugly head again. So I'm optimistic that science is going to come up with new cures. I'm skeptical that the human population is going to accept them.
Gotcha.
I have so many thoughts, but I know we need to wrap up. So I might have my thoughts next Wednesday on this whole thing. It's very altered carbon. Like, are you going to be a pure human or a amended one? I love the fact that we no longer need nanobots. That's a new thing to think about. If they're just creating new fucking proteins. Oh, I swear. I'm sorry. I don't know if we're allowed to swear on this thing. New proteins that are just just one. That's all where FCC allowed. So, they're creating new proteins. They don't need nanobots. Remember, nanobots were the coolest thing. Now we're past that. We have new proteins. And I love having the open data to be able to move science forward. That was the big takeaway that I got from all this. Not only that it was created and reduced the amount of work to be able to leapfrog us in such a capacity, but the fact that it wasn't gatekept. And that gate-kept. That is lovely news, the good for all. So I absolutely love that. So, but I know we're over time, but I have lots of thoughts. So next time.
Danielle, if you want to continue to discuss those thoughts, you can always jump into our Slack community with all of the great people who are in chat right now at dailyaishowcommunity.com.
Ooh, wait, we have a Slack community? Again, I didn't know how to set my alarm. So somebody needs to send me the linky boo for that Slack community, and I will join and jibber jabber away. We love Slack.
Excellent.
Perfect.
Well, like Danielle said, we're going to wrap up for today. Any last minute announcements or anything before we close up for the day? No? All right. So I want to thank everyone who joined us in chat for today and everyone who's watching this just a little later. Remember, you can always, like we've been talking about, join the community. This is where we get some of the greatest discussions, and also let us know what you want to see or what covered in the AI world on the show. Make sure to click the things that make the dings, and everyone, keep your minds and your hearts open. Aloha.